We switch from biology to architecture, and I invite Siobhan Rockcastle to the floor. Here you are. So you're an architect, you're in Oregon, but you also have a fellowship here at the Technical University of Munich, and you have a PhD from EPFL Lausanne. And you work also at the intersection of research and practice. Amongst other, I read that you co-founded a company, so you're an entrepreneur. So that fits perfectly with our topic, from knowledge to action.
Wonderful. Thank you. Can you all hear me okay? Is my mic turned on this time? Okay. The right mic is turned on now. So I want to start just by thanking the Daylight Academy for the invitation to have me come and speak today. This is a really exciting topic for me because I'm not so much talking specifically about my university research, but about the translation of research into practice through the company Oculate Dynamics, which I founded together with Marilyn Anderson, who's in the audience, and Maria Mundadotter in 2017. All right, so designing healthy daylit spaces and really that focus on that intersection between research and practice. Quick conflict of interest disclaimer, because whenever I travel in a professional capacity through the University of Oregon, I also want to disclose that I have an ownership interest in this company, and there is a relationship in the subject area that I'll be presenting today. So Oculite was founded in 2017 as a way to provide daylight design support and consulting around the topic of human-centric daylight performance. And we categorize that as these sort of three pillars of emotion, vitality, and comfort. And I'll talk very briefly for the sake of time about each of these and then sort of move into how we've applied this in the professional sphere through our consulting work. By emotion, I'm talking about the promotion of positive visual interest and encouraging dynamics of daylight. Vitality, which is a non-visual response to light and a recommended healthy dose. And then finally, comfort, which is kind of this dual task of achieving adequate task illumination while also avoiding glare-based discomfort. So again, this is the part that I'm going to breeze through very quickly. During my time at the EPFL in the lipid lab, I developed an algorithm called spatial contrast, which is a prediction model for visual interest. And so to create this algorithm, we did experiments where we showed different images of architectural scenes under different sky and lighting conditions, and then had participants rate those scenes for the degree to which they might feel exciting or calming. There was many other subjective scales, but this is the one the model's based off of. And that algorithm, which is sort of this mid-level contrast within the sort of high density resolution of an image, allows you to predict a percentage of subjects that might rate a scene as being more on the end of exciting. And this is the case of the Serpentine Pavilion, or more on the case of being calming. And this had to do sort of with a good relationship between prediction algorithms that found that sort of density of that contrast across the scene. We did several other experiments that kind of grounded this in more three-dimensional 360 representations and developed a way of taking these prediction algorithms and then mapping them onto three-dimensional renderings so that we could apply those algorithms to different view directions within a position and then map it across space. So you can see this is the Ryerson Student Learning Center by Snohetta in Toronto, and we were able to compare the sort of frequency of view positions that would fall more in the exciting or more in the calming or neutral spectrum, which is directly impacted by sunlight patterns and contrast in the field of view. Simultaneously during this, I got to work in this fantastic lab that was surrounded by people in very different disciplines as myself. My colleague Maria was working on models to predict non-visual responses. And I think we're all sort of more or less in this audience educated on circadian rhythms and direct effects. But in a sense, in short, different aspects of light and dark cycles like brightness, intensity, wavelength, duration, timing, and history can trigger a combination of non-visual responses, both direct, so more like melatonin suppression and alertness, as well as entrainment to our circadian rhythms. Maria developed a model called non-visual direct response, which is has light as an input and then looks at dynamic behavior and outputs a kind of response, which can be turned into a sort of recommended dose. And the thing to understand about this is it is integrated over time, so it's not looking at instantaneous light levels as the sort of output, but it's looking at how exposure to higher intensity light over shorter periods or lower intensity over longer periods can produce this kind of nonlinear response curve. And then much the way we did with this other metric that I mentioned, we were able to apply this to this 360-degree approach where we could then predict that response as it accumulates in a specific view direction over time. You'll see different colors pop up in this presentation because this is really sort of an evolution of that research as it moves more into the simulation sphere. We also integrated existing metrics around brightness and glare avoidance. So in that, we were trying to predict whether or not a space was bright enough to be to provide visual acuity, but also avoiding light levels that were going to trigger a glare response. So you'll see arrows that are yellow for comfortable and red for potentially at risk for glare. We did that, we presented this work mostly in scientific context, and we had architects start to approach us to say, great, can you apply this to our buildings? And at the time, this was really quite intensive in terms of time. So to produce, as you can imagine, hundreds of view positions with different sky conditions and time steps and 360 images that we then applied algorithms, it was just a lot of data. So we had to then spend the next year sort of working on packaging this into a kind of a back-end software. We were awarded an InnoSeed grant from the EPFL, which is sort of a startup incubation grant that allowed us to develop this front-end interface, which we called OcuViz. And both of those things, a condition of that funding was that we incorporated a company called Oculite, which we did in 2017. And then this is what we use to do our design consulting. We've worked on a number of different projects across Europe and the United States over the years since the foundation of Oculite. We have many new construction projects, and we have worked with designers and developers alike who are interested in exploring these topics. I will very much say, and I think Marilyn can agree, we're not very good at marketing our services. People sort of come to us, so they're already opting in to this idea that they're trying to do something a little bit different than standard daylight consulting. So I will say we have a biased representation. They're already interested in this sort of human component. But we've also worked on sort of post-design evaluation, more speculative projects, and renovation projects. And I'm just going to walk through a couple of these very briefly. So the first project that we worked on for Audemars Piguet, a manufacturer facility in Les Seigneuls in Switzerland. And this is the first project that actually was built and constructed that we felt like we had a significant impact on the design. So we worked with the architects to look at this kind of common social space in the middle of the facility that had these daylight penetrations open to the sky, and worked with them to kind of design these light oculi that created concentrations of sun patterns down onto this lower social space, but also sort of trying to balance. This is an image of our front-end interface where we could represent these different metrics that we had now loaded into this kind of navigable interface. And you can see the visual interest metric. So they were interested in not only having comfortable lighting, but also having high levels of visual interest in those social spaces to create more dynamic conditions that would kind of draw people out of the workspaces and into that social space. We also did a project a couple years ago. It was a post-design project with Meyer Partners where we looked at some of their more well-known buildings in terms of integration of light. So we were able to analyze the Jubilee Church in Rome, as well as 2 different residential apartments in the Surf Club in Miami, Florida. This was a really fascinating opportunity because in many ways the Jubilee Church was designed entirely around solar geometry. It's a series of these concentric shells that block direct sunlight. And we were able to show that while it did a really good job of avoiding glare because it was blocking a lot of that direct sunlight in the field of view, that high dynamic contrast also provided very high levels of visual interest. So it is possible to have high positive contrast to promote visual interest, but also avoiding that discomfort risk from glare. We also looked at the health potentials. So this is an application of that vitality metric between 2 apartments that have very different floor aspect ratios. So more of a deep matte layout with a lot of perimeter lighting, but also dark spaces at the core, as well as a double height space that was sort of wrapped in windows on 3 sides and had very high levels of daylight penetration. And obviously you can see here in the center that you're getting these kind of areas of sort of inadequate light dose because you're just not getting daylight that penetrates that deep in. This was the first project we started to experiment with this idea of like unraveling a human through the data. So rather than sort of just looking at the spaces as a sea of performance arrows, we wanted to understand how the people experienced these points and could create kind of a light path. So this was us walking an occupant from, their morning, waking up in the bedroom, in and out of the kitchen, getting coffee breaks, working in open spaces, spending time in different aspects of the residence. And then this was also us starting to get really intrigued by the fact that some spaces kind of inform healthy profiles because you can't sort of get away from the daylight. There's daylight in every room. I think this building is actually a good example of that. And other spaces where if you are more of a perimeter dweller, if you opt into well daylit spaces, you might be able to get that sort of light recommended dose met. But we called this our pandemic teenager. Our core dweller who sort of spent all the time in like the dark media room in the center and sort of just went in and out to get like snack breaks in the kitchen. That was better daylit. And so these two very different users were living in the same residence, but actually experiencing daylight very differently, which became a very kind of fascinating concept for us. And sort of some of the emphasis behind our work into a term I'd call like light equity, but for sort of trying to promote access to daylight between occupants. We then sort of furthered this with a collaboration that we did with Velux for their Living Places project. I'm sure some of you have visited this showcase house. And so what we did in this project in particular was look at kind of optimizing the placement of windows so that we could provide daylight to people that were living in the space as they might move across this house into different spaces over time. So we kind of moved existing skylights, added more skylights and windows in spaces that were underlit, and we're able to sort of nudge the sort of light dose up, even under overcast sky conditions, looking in February and trying to show the frequency of view directions that achieved this recommended dose. You can see that kind of increasing between these reiterations. We then again kind of use this light path to walk you through like a day in the life of this house as a resident and develop this little animation to kind of illustrate that. So that's waking up, moving down into the kitchen for your coffee, working from home in this space that was adjacent to the windows, moving up into the home office, and you can see the kind of circadian exposure through this melanopic log lux kind of building over time under different sky conditions. And we're kind of compared this to the before and after to show that we could use window placement to sort of nudge that exposure up. The last thing I want to end on is sort of work that I've been doing over the last 2 years through the University of Oregon with an architecture firm, Quinn Evans, in the United States. This was funded by an American Institute for Architects grant and Upjohn Research Initiative. And we are designing a circadian daylighting design toolkit and guide for existing buildings, really with a focus on renovation projects. A lot of the work that we've done in the past was sort of assuming that you could optimize, right, and just add more windows, but in buildings that might have historic preservation criteria, this could be more challenging. And so through this, we sort of refined a metric that is existing that was proposed by Sarah Safranek and Bilal Abushi in 2023. It's this kind of melanopic daylight autonomy, which uses slightly different thresholds and color ratios, but we're essentially simulating melanopic lux at eye level in the morning hours, and then sort of looking at the frequency of sort of positions that achieve that dose for at least 50% of the time. And so it kind of creates a representation where if you're getting in the yellow, it means you're achieving that more than 75% of the time, and the orange is more than 50% of the time. And then we are looking, at the influence of window to wall ratio, material reflectivity. You don't always need bigger windows. Sometimes you just need more surface reflectance in the interior scene in order to drive up light level at the eye. And then we are running a series of different kinds of, interventions like interior wall materiality, furniture placement, light shelves, shading, you name it, ceiling height, and then looking at kind of quantifying the impacts with this metric. Really with a focus, this is on a school renovation before and after, looking at the influence of brighter materials and larger windows, and then being able to quantify the percentage of view positions that achieve that recommended dose. And I have many more examples that I will not show here, but I will say that we are planning to release this in the next 4 weeks, and we will have a open access downloadable toolkit for this. So we'd love to get feedback, and hopefully that helps designers with some rules of thumb and some tools to be able to evaluate this in their own projects. Thank you very much, and I'm happy to take questions.
Thanks a lot, Siobhan, for another very interesting talk. So we have time for questions.
last part. How does, if you've looked at that or plan to, millinopic daylight autonomy with basic daylight autonomy simulation or with lead requirements or well requirements?
Yeah, so we did base the two thresholds in the metric off of the well requirement. So the previous metric had this kind of like linear weighting between 0 and 250 on the lux threshold cutoff. And we use the two well thresholds for like 150 and 275 because we're using EML. And so we're kind of giving you like partial points over the first threshold and then up to full points for the second threshold. We've not talked directly too well about this, but we would love to do so because right now, well allows you to meet those recommendations with electric light or daylight. And because it's hard to achieve them with daylight, people will just design the electric light solution. And for us, that does not encourage the use of daylight to get you more of the way there. So we are hoping with a metric that can positively quantify the impact of daylight, that we can actually encourage people to maximize the ability to meet that dose with daylight. So that's the emphasis behind it. It doesn't track super well to spatial daylight autonomy because view direction is so important. So you can have the same seated positions that are looking away from the windows and not getting that dose met. But that will be part of an upcoming publication where we are looking at the sensitivity of that. Thanks.
Thank you. Thank you for the fantastic presentation. I was wondering in the light exposure over time, no, especially in the human behavior, are you also thinking about the outdoor spaces to include them? I think that could be interesting to also compensate for spaces which are maybe not so well lit, to consider them also, especially looking in the whole day. And the second question is, could we apply these models also to urban outdoor areas in the cities?
That's a wonderful question. So we have limited so far to indoor occupation because it's been more about helping shape the design of those environments, whereas like we can't necessarily control what people experience on their way to work or on their lunch breaks. But we did in the Meyer study have our occupant go out on the terrace, so they have a huge boost when they're going outside. And I absolutely think you could do this, where you could start to account for people's outdoor behavior, like how they commute to work and whether or not they go outside at lunch. I do think that could help compensate for these more light deprived spaces. And I love some of the work I've heard today from different folks who are looking at like behavioral nudging with, apps and, devices that can tell parents, like, take your children outside. I think this can be part of the solution and would be super interesting. Yeah. Thank you.
I have a very random question for you. So years ago, I was traveling in Scotland, and I remember one of my colleagues staying at her home, and she has this huge window on the roof that she says, well, this is a moon roof, right? That there, because they have such long winters and long nights, that actually like celestial light at night was also an important part of the architecture and culture. So just out of curiosity, it seems like architects focus a lot on daylight, and I just wonder, does like celestial light ever come in, or is nighttime ever brought in as a factor?
I love question and answer sessions because that is the first time I've heard about celestial lighting, but I love the idea because I think it is. Where I can say it's come in more is when we've analyzed like far northern climates, and we get these like very prolonged twilight and dusk conditions, which are not very bright, but actually have a very profound sort of emotional effect to them. So I think that, latitude plays a big role on that. I can't say that we've ever looked at celestial or moon as a driver. It's not very intense, right? So it wouldn't have a desirable effect on the vitality metric. Also, you should be sleeping then. But it would be interesting from a view perspective. Yeah.
Thank you for the talk. I have a question. The more windows you add to the building, are you also concerned about light pollution of the night? And what do you propose to,
Yeah. So admittedly, we've only been tracking light exposure as a positive in these metrics, assuming that if you get it during the daytime from daylight, then it's going to have a positive effect. These models are not taking into account undesirable light exposure at night, which we also want to avoid, both from electric sources or light pollution through outdoor windows. But that would certainly be an important design consideration in an urban space for you to have light trespass. It's great. Great point.
Yeah, thanks. Thanks for the metrics. And how do you measure these metrics? And does the season play any role in this? Because we have huge differences according to latitudes. So
yeah, so in the Oculite approach, we use weather files that are latitude dependent, and we're looking at a combination in this case, not of like sort of statistical sky models, but comparing clear and overcast as the kind of two dynamic extremes, I guess, for any individual time step. In the latter, that is also weather file dependent, and it's looking at statistical sky models. So in Portland, you're going to have a lot more overcast skies. It's taking into account that, and also the solar geometry that's driven by the latitude in that location.
but you don't look at the thermal balance. You don't look at over temperatures, or
not in this research. We have done some projects which I didn't talk about, which are using some energy models in this case to balance solar radiation and thermal mass, but not in this work directly. No. And there's always more things, right? That if you optimize for one, you're going to start to have issues in the other. Yeah. Okay. Sure.
Many thanks indeed. I just add a slight note of caution with just restricting your measurements to melanopic lux. As you will be aware, of course, the rods and the cones are contributing to those melanops and ganglion cells, and Dacey's work on the macaque would even suggest that the short wavelength cones could be inhibitory. And so in a sense, what we really want is a measure of overall effects of natural light.
Yeah.
And so I just sort of wondering about your logic for just focusing on melanopic lux.
Yeah, well, I mean, to me, there are numerous non-visual effects that are occurring as a product of light exposure, some of which we know, many of which I'm sure we have not yet discovered. To me, this is a moving target. We're putting this out there because there are existing models in this, but I am very interested in the effects of different wavelengths on things, even like myopia onset, and how we can use these kind of human-centric workflows to integrate knowledge as it emerges. So I'm looking to people who are developing models in this area to say, hey, have you thought about applying this novel photoreceptor? And I would say, yeah, let's do it. Let's track. Yeah. Great.
So thank you for the very interesting presentation, and I'm very cautious of time, so it will be a very quick question. Have you already introduced the points of improvements to the relevant regulatory or permit authorities in your jurisdiction to initiate a positive change?
Yeah, I'm not sure I'm gonna have a lot of luck in that in the United States in the next couple of years, but I think that's a very good suggestion. I think that this work has, there are rating systems that are implementing these metrics as a way to sort of encourage designers to go beyond the normal codes and standards. But if I could imagine a perfect world, there would be regulation that sort of enforce the fact that people have a right to a certain amount of light dose in a building. So not yet, but yes, it's a great goal. All right, thank you so much.
Thanks a lot for a fascinating talk and discussion.